Hello everyone and welcome to section 2, preparing to draw objects. In this section we're going to start by being introduced to shaders, where we will learn about shaders and how the graphics pipeline works in OpenGL. We will then move on to creating a camera, where we're going to learn how to create our own camera as well as a canvas to draw all our objects. We will then move on to creating our first shader, where we'll create a vertex and a fragment shader which will draw a textured sprite. The next step will be to create a base drawable object, where we'll create an object that we can extend from, which we'll draw to the screen. And the final video will show us how to get textures across multiple platforms, so how to get textures from Android and iOS so we can use it in our drawables. In this video we're going to learn about what shaders are, we're going to learn about the OpenGL rendering pipeline, and we're going to learn about GLSL. A shader is a program that is used to perform shading, which is run on the rendering pipeline. There are a number of different stages that can have their own shaders. First, the vertex data is populated and sent to the pipeline. A vertex shader is then applied to each vertex, typically moving them from screen space to world space. There are then two optional stages. First is tessellation, where the vertex data can be split into smaller primitives. A use for this is for making a 3D model higher detailed when close up. The next optional step is the geometry shader, which can take the previous vertex data, transform it, and move it to the next stage. Geometry shaders can also be used for level of detail changes. The next stage is Vertex Post-Processing, where the primitives can be clipped. Then, the primitive assembly, where the vertex data is assembled into primitives and faces of the primitives are called if this is enabled. The next step is Rasterization, where the primitives are rasterized, which means the primitive is broken down into fragments. The fragment shader comes next, where the fragments are processed and they're coloured using colours and textures. The final step is the per sample processing, where the fragments from the fragment shader are processed and the data is written to the buffer. The two main shaders that we're focusing on are the vertex and fragment shaders. We'll be creating a vertex shader that passes the data for the vertices into the fragment shader. Our vertex shader will have variables for the position, the colour and the UV for the texture. A UV denotes a position on the texture between 0 and 1 that maps our sprite to the texture. The fragment shader is going to colour our fragments using a colour value we can pass in, and the colour sampled from a texture we provide. Shaders are written using GLSL, the OpenGL shader language. At runtime, OpenGL will compile these shaders and then link the two shaders together to form a program. There are three types of variables that can be found in OpenGL. First, there's the attribute variable, which can vary per vertex. Next, there's a uniform variable, which is a variable that may change per primitive, so for example per quad. And finally, there's a varying variable, which is one that is interpolated from vertex to fragment shader.